All right, this is a test for the SMD version of the ULN 2003. And I have 20 of them. Here it is. And I only took one here. And I have 10 on this side and another 10 here. And ULN 2003 SMD. I believe they are SOT version, not SSOT, which is stupid tiny. And they are even more stupid tiny than that as well. But this is quite manageable for soldering. It's okay. It's okay-ish. Definitely is not as easy as with a deep version that I'm having here. So what I'm having here is a test. I wanted to test if this is functioning, and it is. It is driving exactly like with that other chip. I replaced it. I took it out from there, and I replaced each input and output pretty much with a wire, with a testing wire. This is having a very long negative wire to here. So is this pin here very long to the negative. Two inputs, two outputs, but not this positive wire here. As you can see here, it remained this link, this positive wire from that chip when I was testing it, but it doesn't really need it because it is working without that normally, you know. Yeah, it's still on 3 volts. It's the same setup as before. Nothing is changed. I only changed this integrated circuit just to test if it's something different in this SMD versions from those deep versions. If it's different, because I had some unexpected problems with other SMD chips before, so that's why I'm testing these SMDs instead of those deep versions. You know, that's my reason. So it is working fine, and this is great news actually. All right, that's it, and voila! Surprise, surprise! I made it on the cardboard. I'm not completely sure why I did it, but I did it anyway because it is a fun project in my opinion. So it is working fine, as you can see. I used here this 0805 size of the LEDs, not 1206, which is a bit bigger. I'm starting to get the hang of this 0805 a little bit. They are still hard to deal with, to solder them, but it's it's interesting. So right now it's working absolutely perfect. I kind of mixed the logic a little bit, but it's the same logic there, but I mixed the wiring. So from this output is going directly to this transistor here, and this transistor on the right is actually that transistor on the left. I know it's very confusing. This transistor is putting positive on this first pin here where the red wire is, and the second one is putting the output to this other pin, if I remember right. Let me show you the underneath of it, how it's looking. I put a little bit of paper there. I glue it very securely not to make short circuits, and I am on the limit with some wires, so that's how it's looking underneath. It is working flawlessly from the first try, and I'm very impressed that it is working completely fine, as you can see. It's the same circuit that I used before on the breadboard there, but I desoldered the wires, and I changed the wires with these new ones, and it's perfectly fine. Working as a dream. So I replicated that circuit, but I changed a tiny little bit the order of things, and I'm using this last gates from the ULN 2003. Doesn't matter which one you are using. So in my case, I'm using this last two for convenience, because I got this point. I could link it directly to that base of the transistor, and then to this pin here. And you can actually see, this wire here is from here going to the base of this transistor and going directly there. So that's the convenience. And another convenience I had, this pad is actually a long pad there, which is connecting this middle pin of the transistors, both collectors. And as you can see here in the diagram, collector, they are both to positive rail. So it was another convenient thing how to mount them. Unfortunately, this transistor is having the base here on the top and emitter on the bottom, while this one is inversed, is having the emitter on top and the base on the bottom. I marked everything there, and in the middle is the collector. Is a tiny little bit of C there, but then I made a positive sign. And that's it. This is a little bit of funky business, but the logic is the same logic, and it is doing the business. Now the hard part is to actually make the mechanism of switching and the stopping bits, not with that wire, to actually work on this part, and to make that LED and LDR pretty much, or some kind of contactor that is signaling when it's on, when it's 1, and when it's 0, like that. So that's how it's like. Yeah, it's I'm not completely sure if I will make more than one. Probably this will be the first and the last one that I will make, but it's still powered from 3 volts, as you can see. And that's it. All right, here it is. Hello to everybody from your favorite artist electronist, Mr. Q12. I made this non-volatile or persistent memory module, at least a percentage of it, and it is functioning fine. If I'm pressing this button, you can see it is changing sides. And now let me present it to you because it's quite interesting. This is a piece of cardboard that I glue it on top of that rotor that is having there with tiny bobbins inside. This is a piece, you can see it here exactly where I'm pointing it right now, is a piece of wood. But it is a matchstick actually, for this cardboard to be perfectly aligned on one side and on the other side. This cardboard is glued with that Prelandez, which is a shoe glue, very strong shoe glue, and it's it is adhering sometimes to plastics as well. So this cardboard that you are seeing here is glued very strongly to that moving element that is having there, the rotor. Okay, next. So I made, this is the back of it, and I made this surface from plastic, melted plastic, manually melted plastic. As you can probably clearly see that everything is made manually, and I put that matchstick there. And the biggest problem and the biggest issue that I had was this L shape that you are seeing here, this black L shape. Originally, for half a day actually, almost all day long, I used this melting plastic like that, which is like a wax when it's melting, very liquid, and when it's liquefying is getting inside every crack, and it's very good on the flow. But here it was cracking, it was too sensitive. I had a ton of problems with it, because to center it on this element, I'm not sure if you can see, let me do it like this. Yes, you can see, you see that white gap between the top side and the bottom side. That's I'm not sure if you can actually see. Let me zoom in actually. Let's see if I'm zooming in. Maybe I'm lucky to actually catch. No, I'm not lucky. But there are two brushes there that are pushing up this upper element. So those brushes, there are two brushes like this, and the top side is staying on those brushes, and those brushes are elastic, and they are pushing back up this very light element that is on top. And this element that is here, this black L shape, is having the role of pushing a little bit back. Let me actually draw it for you. This is the bottom of the motor, which is containing the magnets, permanent magnets. And here is the axle. Here is the axle. And here is the brushes, which is like this, the brushing. And it's pushing up this element that is on top here, the rotor. So it's a gap. You've seen that gap between these two elements. And this is the rotor here. And this top element, which is like this, is pushing not too low, not too high. So this rotor, if I'm pressing it too much, it will touch the magnets and it will not permit to rotate anymore. And if it's too high, the brushes are not making contact with the commutator that is having underneath. So this is the plastic, this rotor plastic is having a hole in the middle for the axle to get through it. And then it's having this tiny, like this. And I believe they is having exactly 6 commutator plates. And the brushes are catching on one and on the other side as well. And there are 2 bobbins here inside, 1 and 2. And that's the thing. And next, when here, actually I will make a little dimple like that. And that dimple is actually this axle. So this axe of the motor, that is a little bit higher than the rotor itself. So the rotor is moving up and down and leaving a tiny little bit of the axe on the top. And the hardest, the biggest challenge that I had was to make somehow this plastic head that I'm having here, but so like this, but with a hole in it, like that, you know. And this is the plastic head, and with a tiny little bit of hole. Doesn't matter how it's made, but it's important to be centered good enough and to permit that little dimple to enter a little bit inside. And this was killing me, because it's very tiny. It's very tiny, and I literally couldn't see shit without magnifying glass. Only with my eyes and with my trembling hands at such very small dimensions is killing me. And I tried to make it from this plastic, white plastic, like I said, it's like a wax. And if you don't center it perfectly vertical like that, if it's a little bit too in the front or too in the back, or if it's on the sides, if it's not perfect but good enough centered like that, like here, the motor will, and this was the case all the time, the motor will move only a little bit, and then it will grab that thing that is on the side and that is not centered. And I had to move it with my hand to kick it to go to the other side. And when I press it back, it was stalling. It was staying only there and not moving there. And when I was forcing it, it was moving back. And I had this problem a ton of times. This was the main principal error handling that I had to do with this particular element. This was the main issue, the biggest problem that I encountered. And like I said, I made it with this plastic, and it didn't work. I made it like probably 20 times. Not 2 times, not 5 times, not 10 times, but probably 20 times. I took it out, I remodeled it, I reshaped it, I tried to make this very, very shitty hole there. And when I thought that is good enough, then I couldn't place it good enough here, centered. And Holy fucking shit. And this was cracking at some points. I had a ton of problem. If I was forcing it to bend it out of, to recenter it, I had to remelt everything here and position it. And I got it right 1 or 2 times. But when I got to insert, to put this LDR here, this is the LDR, and here is the LED. It's a SMD LED here, but the LDR is a true hole. And when I made the hole, the 3mm hole that I'm having here for this LDR to fit into, the vibrations from the machine, when I made the hole, it decentralized everything, and it cracked the plastic probably, and it didn't work after that. And fucking hell. So while I was working on this thing, numerous times it got decentered. And then I made a pause. I made many pauses actually to stay in sync how to do it. I was thinking to actually file out this little dimple to flatten it, but then I said maybe I should try another plastic, another type of plastic. And this plastic that I'm using here is this PP, which is very polypropylene it's called. If you don't know what type of plastics you have, you should look on this signs, and if it's a 5 or 0.5, or actually write it there PP, then it is this type of plastic that I'm working with. And this is the white plastic, the PP. Okay, on PET or 0.1, this is believe it or not, is this transparent plastic here, but usually from beer bottle. This is the plastic that I use, but in this case I use this transparent plastic, and it burned out and it got brown here. It's looking like it's black. It's looking like I use this guy here, but in reality I use the transparent thing. And it is very, very solid, and the melting point of this PET plastic is a little bit higher than the PP, and the PP is getting very quickly melted, and in a very it is becoming extremely liquid very quickly, while the PET is like caramel, exactly like a caramel. Is very gluey, and is very is moving very slowly, and is grabbing all the time. Is like you have to force it a little bit to actually mold it into place, which is good. It's good because I combined this shape with this PP, and I didn't intermelt them each other. I use it as a separate one on top of the other, and I put the PP plastic around it like that. So this PET plastic, black PET plastic, I actually I put my iron on this cylinder, which by the way I made it by hand. So I hold it in my hand like this, and with my iron I was like that. I was moving like that along it, and then I was rotating it a little bit, and then again and again and again, and rotating, and then moving until it got semi-round or round enough, cylindrical enough. And after that I flattened the side here, and while it was still hot and was liquid in semi-liquid shape, I pressed onto that head here in this area, and I made a perfect dimple that is there. And then so it became like that with a little dimple. And after I put the dimple there, I put this, I made the shape, the L shape like this, and I press it into position, and I looked to be quite perpendicular, and then I put a lot of white plastic around it here, and that's it. It is poorly held here, but I can probably pour a little bit more on the top here as well. But this was the hardest part to make. This very extremely delicate balance, not too high, not too low. So to repeat, if it was too low, it was grabbing or touching the magnets, and it was not moving. If it's too high, the brushes are not contacting, and sometimes it's moving, sometimes it's not moving. And so it must be pressed, not too much, not too little. That's the idea, with this L shape that I'm having here, not too much, not too little, just in the middle somewhere to be. And it's pretty fucking hard, extraordinarily hard. This was by far the hardest part to make it work. Why this shape, you are asking me? Because to permit this cardboard to move on one side and another, like it's doing here, and it's doing it flawlessly, without any interruptions, without any grabbing. And I have 4 tests for it to make. This test one is horizontal like that. Another test is when I'm holding it like this on one side. I know it's stupid, but you can see it. It is moving up and down, which is good. And another test is like this, because in my previous tests that I did, the similar test that I'm doing here with other L shapes that I had, when I was moving it on one side was working, on the other side it didn't work. So this is a good test to make, to show you that it is doing what it's doing. This is the 3rd test, and the 4th test is when I'm holding it upside down, and this was, and you can probably see it here. You see how it's moving? It is doing the job. This was, in most of the cases, this test upside down didn't work at all, and because this rotor was moving outside the contact of the brushes, and it was killing it. So I start to really think very hard on how to make it, and in the end I did make it as I did it before, but with another material. That's the idea. I was thinking to make it from metal, to shape it on my lathe. I have a lathe, but being so small and the hole so fucking, it's horrible to work, and I didn't even start to do it anything. In the end I concentrated only on plastics to make it from plastic, and it worked. But it's very, very fragile, extremely fragile part what is having there, very, very fragile, because of that balance. So that's about that. And next is the LDR, which is this thing which I press fitted, and then I cut with my with this cutter. I cut the margin here because it was entering, but not really to the maximum here. It was staying too much here outside, and then I cut this side, and then I reglue it, I remelt it, and make it liquid very quickly. Like I said already, this is becoming very easily liquid, exactly like a wax is behaving, this PP plastic. And then it got perfect. Right now it is very strongly press fit in that hole. It is not moving around at all. And this is a SMD LED. Unfortunately, you cannot see it at all because it's white on white. The LED is white and the material around it is white. But it is, I'm telling you, it is here on the margin, right on the margin here, and it's more or less perpendicular to that LDR head. So this is the reading. This the LDR actually is the reading element, and the LED, it will only flash, stay lit while I'm taking the reading from the LDR. When I finish reading, the LED will turn off. That's the sequence I'm thinking to make this this thing, not to let it staying lit all the time. Only when the reading is happening, then the LED will get on and off. That's the idea. And other than that, this circuit that I'm having here is most probably only temporary, only to drive this motor. By the way, if you don't remember, I have to refresh your memory. This is an H bridge, and pretty much what is doing is putting positive here, negative here on these two wires of the motors, and then it's switching. When I'm pressing this button, it's switching the polarity. It's putting here positive and there negative, so it's doing this vice versa. This is the role of this top circuit that you're seeing here. Two transistors and this Wulene 2003. On the LEDs here, these two LEDs that you're seeing, there are also for show, but I'm actually getting the signal from these two pins, which are here and here, these two pins, and I'm getting the signal from there directly on the bases of these two transistors, and also on those pins as well. And this is a flip-flop that is doing only the flipping. This is the button with the bouncing circuitry inside. I already presented it in another movie, so I will not talk about it too much. And that's it. This is the circuit, and like I said, this is most probably a temporary circuit for this device, because the actual sending and receiving data from this non-volatile or persistent memory device that I made here will probably be something else than what I'm having here. Most probably, I'm not completely sure, but we will see how all this circuitry will evolve. Also, let me show you that the LED is working fine. I didn't fuck it up. So here is a test only for the LED. So I have to put out this. So here is plus, here is minus, and probably you will be able to see. Yeah, you see. Let me close the lights to have a bit more contrast. That's the LED. It's a yellow LED. Doesn't matter the color. It matters that it's shining there. And that LDR, I tested it already, is brand new. The LED is also brand new. So I used two scrapped transistors here. And by the way, one of these two transistors, I used it for another test before, for that auto blinking LED, when I had to use a transistor to amplify the signal, and it was keeping the LED on too much on. And it's one of those transistors, exactly one of those transistors. But in this particular case, it is not amplifying, it is only a switch, and it's perfectly fine for a switch or as a switch. Even if the amplifying is a little bit off, so it's not amplifying like it's brand new. So the solution for that auto blinking LED with the transistor inside it was to change the transistor with a brand new transistor, and that made the LED turn off completely, or 99%, because it was having a little dot, if you remember, inside. But it was turning it on and off. It was flash on off. It was a flip-flop, pretty much. It was a flip-flop. When one was letting up, the other was letting down, was turning off. And when this was turning off, this was turning on. But the problem was this was not turning off totally. It was still remaining on. With that, with one of these transistors that was not amplifying, well, it wasn't doing. It was. It is a little bit stressed internally from something. I don't know from what, but it is a scrap transistor, and for some reason it was letting a little bit of current passing through it, while it should have been stopped, that current to pass through it. So that was the issue. But in this particular case, is working absolutely brilliant, absolutely brilliant. Back then I was having a little bit of voltage for the low voltage, for the low signal, and for the high signal I was having 5 volts, and for the low signal I was having something like 2 volts, 1 point something. So it was still a tiny little bit of current. So, and that tiny little bit of current was enough to keep it open. But in this case, what I'm having here, I'm having an explicit 0 volts and an explicit 3 volts, because everything is powered to 3 volts. And right now is not a problem like it was before. That's about these transistors. And the next stage is probably, I'm not completely sure if I will even make it, to actually complete this entire module, to make it a permanent, a non-volatile element to insert. So let me draw a line here, to insert an element of stopping. This is probably another matchstick like I used here. So this is the bottom matchstick that I'm having. This is the axle of the motor. This is the cardboard on this lower matchstick, like that. So this is the cardboard, and probably here on the top will be another matchstick, and here something like that will move away, so like that, this matchstick, to permit the rotation of this cardboard, like that. left and right. So this will go back in the back. It will retract in the back. So pretty much I will make it from a side. So this is the matchstick, top matchstick. This is the bottom. This is the cardboard here. This is the axle, and this will retract probably from here. It will become like this. You know, it will become like this. It will literally go back, lift. It will lift and leave the space here for this element, for this cardboard to move back and forth, and then get back and stay back there and secure this cardboard not to flip willy-nilly. To actually make it persistent and not move, you know, that's the idea. But I'm not completely sure if I will make this other element, this final element actually, this stopping element. So theoretically it will be here. So here on top, theoretically. And it will not permit either in this position or in this position to flip, you know, to flip away on the other side. So it will keep it only on one side, and when is the problem of switching, it will retract somewhere in the back here. It will let the thing to switch, and then it will retract back in front and secure the rotating, the switching that is happening here. That's the idea, but I'm not completely sure if I will make it, because it's too hard. It was very, very hard until here. I'm not completely sure. Let me power it back again. I'm not completely sure why I make it. It was kind of fun to make it. I suppose that's why I make it, because it was fun. But this hard thing that I'm having here, now you see it is grabbing a little bit there, a tiny little bit here in this area for some reason. But yeah, it's good enough. Yeah, you see, it is kind of grabbing. Something got disturbed here. Hopefully, yeah, that is good enough. But it's very, very sensitive, very sensitive. And I had enough with this little problem that I'm having here. Most probably, it's best. I was thinking on this other solution to actually change the motor with my other version of motor. So this is the motor that I was using there, but it's too shitty. And this is probably way more better to use because it's not having such many problems that I'm having there. So pretty much you can put here a little bit of cardboard like that, and it will move left and right, and that's it. You'll not have to deal with this problem issue that I had there. So I adventured a little bit too much into trying to make it work. Specifically this type of motor. Well, it can be put to work, repurposed from a vibration motor into a changing bit element, but yeah, it proves that if I really want something, I can make it, right? It proves that I'm crazy enough to push it to the limits. That's what is proving. Until so far, is good enough what I'm having, and I'm not completely sure if I will pursue to make the other element here, because it's too much. It's already too much. I will concentrate most probably on the next easy part. This is easy part, illuminating this LED and collecting data from that LDR there, and somehow to display it. Probably, I'm not completely sure, with an LED or something. I'm not sure, but that's my permanent element. This is more didactic. This is more explanatory of a non-volatile or persistent memory really works. This is a very educative example of something like that. If you want to learn about it, here it is, my example. So probably when I was adolescent, because I have this idea from when I was adolescent, back in my youth period, and I probably promised myself I will make it someday. And this project that you are seeing here is that desire that I had it in my head very long time ago. Probably I've seen it, I've read it somewhere, and I liked the concept. And it stuck with me in my head, and now I just get into stupid mode, into childhood mode, and I made it for me for when I was a child. That's the explanation why you are seeing what you are seeing here. Leave a like if you like my project that I'm having here. If you want to know how I'm melting the plastic, I'm using one of my I have two soldering irons, which are very banged up here on their heads. They are not new in any universe, so they are very, very worked up. I have to change both of them probably. But this is the main one that I use for plastic, and it's getting to, I have no idea what the temperature is getting, but somewhere around the 300 degrees Celsius, 300, probably even 400, 350 maybe. I didn't measure it, but I should probably. But it's getting very, very hot, very hot. And this was the main tool to work with all this plastic. And pretty much what I did, I used little PP, little segments that I cut them manually myself, you see, in small chunks, and these are the small chunks already cut and prepared there, and I put this element here on this cardboard. Actually I use it here, and you can see a lot of little burn marks. Then I choose a cardboard, I put on cardboard, and I literally do it like this, and I melted it until it got like a little moist, like a little moist wax, and then I push it and add it to the larger component that I'm having there, and little by little I constructed everything around the motor, around that matchstick that I'm having there, and I modeled it and added. It's exactly like working with mud. Exactly like that, exactly like you are building with mud, like you are putting mud and very liquid, you know, in very liquid form, and when you blow some air on it after you finish the shape, you blow some air with your mouth, it's starting to solidify very quickly, in a matter of seconds, and it's getting hard quite quickly, and that's it. And that's how I melted the plastic. The PP, this is how I'm working usually with any kind of plastic that I'm using. Of course, I'm this procedure that I'm using here, this process is very destructive for the resistance of the plastic. But as it is here, it's very cracking. But if you don't stress it enough, if you don't vibrate it too hard, it's good enough. For what I'm having is super good. And also for this PET plastic that I'm having here, exactly the same procedure. I'm adding and I'm making it in hand. I'm rotating it until I'm getting the shape and making the flat, moving it left and right until it's getting flattened. And sometimes I'm putting this side, and while it is liquid, I'm putting this side and press it, and it's getting a very shiny and flat surface on that particular side. And the excess that is creating outside, like little blobs, I'm moving them down with this hot iron, and I'm shaping it. Is like that. It's just shaping. And that's the entire procedure of melting plastic and working with plastic. And I hope, of course, this plastic is emanating a little bit of internal chemicals, burned chemicals, some fumes. And I'm keeping my sometimes I'm keeping my window, but this times I didn't so much these days while I was working here. But my door was open, so my the fumes are not constrained into my room only, but they are living outside my room on the hallway. And that's it about this project. Probably I'm not completely sure if I will actually continue from this stage. Like I said, probably I will add the logic for lighting up this LED, reading that LDR that I'm having there. So I will make a self-sufficing element. I was saying that I will make 8 bits. This is only 1 bit that I'm having here. And I will not, for the life of me, I will not make another 7 of this because they are fucking hard to make. And especially with this type of motor. But probably this other motor is probably better to use than these guys here. But I really wanted to find a new usage for this very flat vibrating motors. That was one of my points to find another usage. And this is another usage, in a sense. But for the life of me, it's so hard. Holy fucking shit, I will not make another 7. This is it. This will be one single bit and that's it. And it's good enough. It is persistent. It's good enough. So another subject is my original idea was to make an easy non-volatile memory module or element with as many bits as I can. It turns out I can only a single one module of this kind there, especially being mechanical like that, and is super hard. This was my idea originally, to be able to make at home a do-it-yourself version of this persistence or volatile circuit or element, whatever, as many as you can. This was one idea. The other idea, and I want to be as clear as possible. So I don't know. Here I'm having some scrapped components from some boards that I didn't want them, but they came anyway. And I will not tell you what this chip is because it doesn't matter what kind of chip is. But as you can see, it's having a ton of pins here, a ton of other pins. So I'm using this chip model that I'm having here with many pins, and it's obviously scrapped from there. But I'm using it as an example. Imagine people will make in the future some chips like this. It doesn't matter if it's having so many pins as this one is having, or a little bit, like 7 or 8 pins, or even 4 with deep 8, or deep 16 or whatever. So a little bit less than, not to be this long, But imagine you have this kind of chips in the future, and you can command them bit by bit. Having an in-out, not like a PIC microcontroller, but like a very simple logic circuit, like a flip-flop, pretty much. On one single pin, if it's on positive, 5 volts is writing. If it's on negative, is reading, and that's it, on the same pins. And you have a setting pin, and on the other pins, you have in and outs, and you program one single bit per pin. So you have 8 you have 8 pins in one chip. If you have let's see, this is 12 here, 6 and 6 pins here, so 8 bits, it means 4 here and 4 there. You remain with 2 for power rails and another 2 for settings, and that's it. And you have 4 bits of memory in one single chip. Very easy to access, very easy to write to it, and very easy to read to it. Not to get fucked with registers, or to get with layers of registers. Come on. So this will be a very good improvement in the arsenal of electronics, to have single chips with very limited indeed, very limited number of bits, but very extremely, this is my idea that I want to communicate to everybody, to have extremely easy to access, to write and to read some non-volatile, permanent or persistent bits from a chip. Because usually you don't need so many if you are doing something simple. I'm not completely sure what example to give you, but if you have a small circuit like I'm having here, and you really want to save the settings for this circuit to start in another way, to start in a specific way, not to reset everything from zero, from scrap, and to actually implement a very expensive PIC microcontroller to actually hold the memory for 1 or 2 bits, to be open or closed. This is stupid, in my opinion. With a ton of memory, and you only use 1 or 2 bits from it. What in the end is going down to is to keep an in-out pin on or off when everything is powered on. This chip to remember which pins to make high and which ones make low, and this set of data to be read by the rest of chipquit, and to be set like that, to set it up with this kind of very, very easy to implement, to write and to read and to communicate to the rest of the chipquit that we have. It's very easy, very stupid. And then if you want, only bit-wise, so to store only 1 bit per pin, or 1 byte per pin, but that's it. 1 byte, which is 8 bits, or 4 bits. I believe that is called a nibble, that is having 4 bits, and 1 byte is having 8 bits. It doesn't matter. But the idea is to have that version as well, which is most probably you have to insert it serially, and that's it. No other protocol. In the moment you access that pin with a stream of bits, you are shifting everything, all your bit data, you are shifting it into its one single register, which is on one single pin, and that's it. One register on one pin, and that's it, which is having 8 bits. That's it. And so it's 1 byte. And you have to shift it serially like that. But I like my version more because it's much more easier to write and read single bits than a single byte, than 1 byte, which can be 8 bits or 16 bits or 32 bits or whatever, how many bits you want to put inside. But I believe for the general electronics, it will be a very good, very, very good and interesting chip to have like that, to store actual bits per each in-out pin. And I believe it can be implemented with today technology that we have, to actually have a little flash memory per each pin. And you can get creative with this kind of chips, you know. It's an idea. I have this idea for a very long time, actually. It's not that I'm imagining it right now, but I hope I'm getting much more clearer now with this explanation that I made right now than before when you watch my other preview movies. And I mentioned it after I rewatched them. I feel that I wasn't as clear as I am right now. So for the guys who are actually making chips, integrated circuits, it should be interesting to make this kind of hybrid, low-level, persistent memory, very, very low level, bit level persistent memory. And also, very, very important part, to be extremely cheap in a high quantity. Again, like these chips are. These are quite kind of expensive, logic chips in general. Usually you get 10 or even 20 for $1 or $2 maybe. But these chips that I'm mentioning to be even more cheaper than those, like, I don't know, 50 pieces, 50 chips for $1. That's very important. That's very, very, very important. Like that. That will be cool. And of course, with as many pins as you can. If you can make a chip with 100 pins, you will have 100 inputs and outputs, and also deep version and SOT version. Little ones. And that will be very, very cool. Very cool to have. And tell me if you agree with me down in the comments. If you are the ones that are watching my movies, do enter into communication mode and write to me if you agree with what I'm proposing here to actually create this kind of low level, very low level, permanent, and most probably with a little flash memory per each pin inside. And yeah, very, very cool idea. It doesn't exist yet, such a thing. I'm proposing it for the first time, most probably. Let's see what if the world will listen to my advices. From Romania, favorite artist electronist, Mr. Q12. All right, that's it. Thank you very much for watching. I hope you like it, and also leave a like. Don't be a motherfucker and press the dislike button. Like I have one motherfucker that is doing exactly that, is pressing the dislike button all the time, and is well, it's not that is annoying, but it's a little bit of motherfucker. And yeah, shame on you. So that's the thing. I hope you like it. Leave a like, and see you later from your favorite artist electronist, Mr. Q12. Bye bye.